Hi Spring fans! In this installment of Spring Tips, we're going to look at the different options for working with servlet containers with a Spring Boot application or from a Spring Boot application. This includes, of course, the embedded containers that Spring Boot supports out of the box. For example, the RedHat Undertow project, the Eclipse Jetty project, and the Apache Tomcat project. And then we're also going to look at how Spring Boot-based applications can be deployed into a servlet container. Now, I want to distinguish all of the support from the support in other web runtimes, for example, that of Spring 5, which is due this summer, for a reactive Netty-based runtime, and that support, for example, that you might find in the Play framework, which is also not based on the servlets sort of specification. So in this discussion, we're going to focus our look at servlets in particular. We're going to talk about options for manipulating the embedded containers, and then we're going to talk about options for integrating with a standalone servlet container or really any Java EE application server by extension, right? So we're going to build a new application. We'll just call it our demo application, or what are we going to call it? We're going to call it Servlet Demo, and we're going to bring in Spring support for building web applications. And we'll build a simple REST endpoint, just something with which we can work. And one thing that I've done here is that I've left the default settings here. I've left the default settings for the application as a .jar. Now I could have elected to choose the .war, but we'll turn this .jar into a .war later on, and we'll see that there's some benefits in doing so. Okay. Now I've got an application up and running. Let's modify our code and create a simple REST controller. So we'll say class greetings REST controller. Okay. At REST controller. At get mapping greetings, and I will say map of string greetings. We're going to return a empty collection. So greeting hello world. It's not an empty collection, it's a almost empty collection. It's going to have one attribute. It's going to be turned into a JSON map. So if we run this application, just run the application on our local machine, we should see that spin up on port 8080 by default. And the reason for that is because, of course, Spring Boot is embedding Apache Tomcat by default. When you bring in the web support, did I give it a mapping? Greetings. When Spring Boot starts up, it by default it embeds the Apache Tomcat servlet container, and so we get a working web server available for us out of the box. Now, this is a servlet container, right? So you can do all manner of different things that you would do in a servlet container using Tomcat, right? This is a servlet container here, right? And ultimately what Spring Boot is doing is it's auto-configuring the Spring MVC dispatcher servlet and framework servlet and so on for you, right? All that stuff gets done for you behind the scenes. And the way we're doing this is that we're embedding Tomcat, and then we're using the programmatic capability of the Servlet 3.1 specification to programmatically configure all the relevant objects that the infrastructure, the apparatus that Spring needs to be an effective web framework on top of the servlet engine. You can participate in all that, right? Spring gives you a chance to participate in all that. You can register filters and servlets as well. You can register custom things that should be registered with a servlet container. So let's suppose I wanted to build a custom filter, right? I can say component class my custom filter implements filter, and this is a JavaX servlet filter, right? It's a traditional kind of thing. Import that. Whoops, wrong one. JavaX servlet filter. Okay, I'm going to override the three methods here, the salient methods, and we have just three methods here. Let's go ahead and log, as a proof of the pudding. Let's create a log, and we'll just log each method in the salient parameters. Okay. So this.log.info init, and there's the config. Okay, and we want another log method here saying that we've received the request. Do filter servlet request, servlet response, and I won't log the filter chain, but I will call the proceed method. Right, this is the contract of the Servlet API, is to call the filter chain after you've done something, after you've pre-processed the request. So every request that comes into the application will get routed through all the filters that apply and that are applicable. And in this case, the filter will get a chance to do something and then hand it to the next filter in the chain, if there is a chain. And so finally, we want to also log the destroy method, right? So destroy, very good. If we restart this, this is already enough. We can already see the results just by registering a component, right? We don't have to talk to the servlet container. We don't have to do anything particular. We just have to declare a Spring Bean of the right type, and it gets automatically plugged in to the request. So we can see my custom filter init is already in place there. There's the application filter config. We can see the details of that. Let's go ahead and make a request to our application endpoint here. A few of these, I'm just hitting Command R, and you can see that as that happens, it says do filter, and then it shows us the request facade, the request or the response facade, etc. These are the HTTP servlet request and response subtypes that Tomcat ends up passing into our method on that request. So already we get the benefits of the filter API. Now, a filter usually has some sort of sense of ordering, right? Some sort of priority. And similarly, you may want to configure other things besides the actual type itself. And so for this, you can register what's called a servlet registration bean or a filter registration bean. So here's a filter registration bean. And in this case, I'm going to return a filter registration bean, new filter registration bean, and I'm going to make it so that this filter is not a Spring Bean. I'm going to instantiate it myself, right? My custom filter, plug that into the pipeline here, and I'm going to say my custom filter, and I can specify all manner of other things here. I can say, I can add initialization parameters, I can add URL parameters, I can say whether it's asynchronous or not. I can specify all the things that you would expect to specify when programmatically registering a filter using the Servlet 3.1 API, including the order, right? So you can specify that as well. You can also get some of that effect. You can also get the ordering just by using @ordered, right? If you just there you go, @order, right? So if you specify a number there on the component and leave it at component, then you don't need the filter registration bean to get ordering in the Spring context. But everything else, if you want to specify all that other stuff, you have to do so on the filter registration bean. In our case, it doesn't really buy us anything to configure anything else. So I'll just leave it as is and restart just so we can confirm everything is still working as expected. Now again, it's worth understanding that there's also a servlet registration bean, right? Servlet registration bean, and servlet registration beans are great if you want to register a servlet, any servlet, right? Servlets that you are used to using, maybe you're using something that isn't managed by the Spring framework for you already. And the nice thing about this is that you can put these beans in an auto configuration, so you can actually do very dynamic things. You can do, if you put them in an auto configuration class, that is to say, a class that is enumerated in the Spring.Factories entry under the auto configuration. For example, here it says @enable auto configuration, and then it shows a list of Java classes. If your Java configuration class lives in that enumeration, it'll respond to the conditional annotations. So you can register all manner of different things based on dynamic sort of tests that are provided for you out of the box. Of course, we've got some very useful conditions out of the box here as well. But if you want to use some of the other ones, you can write your own condition with a conditional annotation. Okay, so that's how you register custom filters and servlets, and you can take advantage of the lower sort of machinery inside the servlet container without having to deploy to a standard servlet container. You may want to configure things for the servlet container, and there's a large swatch of properties that are well supported across all the different embedded container options. So for example, I can specify the port, right? Server.port equals 8010, right? I can also specify things like SSL. So I can say server.ssl, and I pass in the key store, the trust store, the whether it should be enabled or not, all that kind of stuff, and this works in a consistent way across Tomcat and Jetty and Undertow. I can also specify compression, gzip compression in particular, right? So I can say, okay, let's enable it, true, and let's point it to anything that responds with application JSON. So this is a comma delimited list of MIME types that are supposed to be compressed. And so with that in place, I can restart the application, having done nothing else. And now, if I make a request by default with curl, I'm going to make a request without the content, without the accept encoding there, right? I'll make a request like this. get rid of that first. And you can see that it failed because I called the wrong endpoint on the wrong port. So greetings, ED10, and it shows us hello world, right? There's a result, and in the response, the content type is application JSON. It is not compressed just yet. So now let's revisit this and bring in the correct header there, the correct header and the correct port and the correct endpoint. So I'll say content. I'm going to say that I'm going to accept an encoding of type gzip, and that I want to call that endpoint. And when I do, I get binary data back. This is compressed data. Now this is more efficient. Obviously, in this particular case, where I'm returning all of less than a tweet's worth of characters, it may not be that important. But if I were to return a substantial amount of JSON, this could be a very valuable thing. Browsers will automatically decode that for you. And this kind of compression can be super useful, especially for static resources, things like CSS files and images and so on, right? Well, maybe more so JavaScript and CSS, but either way, you get a lot of benefit from enabling compression, gzip compression in your application. And Spring Boot makes it dead simple to do so. So you can specify for all manner of different things that you want to compress them or not compress them. You can also say, I want my resource chain, the thing that's serving up things in your source main resources directory, things like your JavaScript files and your CSS files and so on. Those resources that are going to be piped directly to the client, or perhaps even served from a CDN in an alternate case, those can be gzip compressed as well. So if you have things that are not volatile, they're not going to change a lot, and they're heavy, they're fat, and a lot of they're porous, as JSON, for example, and CSS and JavaScript tend to be, this is an ideal sort of option there. Okay, now sometimes it's nice to be able to configure engine or embedded servlet container specific features, and we've got properties that expose a lot of that for you as well, right? So there's server.tomcat, right? Server.tomcat.asterisk. So, for example, the header the header that I want to expose when I'm doing a forward, for example, the number of threads I want, the maximum number of threads in the worker pool, the max number of connections I want to accept, the base directory, how many processors I want, the background, the access log configuration. I mean, really, just anything you want, you can imagine specifying. Most of that is here, right? Where we cannot do a specific, or where we cannot do a general purpose configuration property like server.port or SSL or compression or something like that, there are sometimes container specific properties, and that applies equally for Undertow. Here's some access log configuration options, and your IO threads and how many worker threads you want, and same for Jetty, right? So here as well, Jetty, how many the largest post size, that seems to be common across all three of them, the number of incoming acceptor threads, and that's a common, albeit different named property across at least Tomcat and Jetty. So you have a lot of options, right? You can configure these things at will, but sometimes it's useful to be able to interact with the container programmatically, right? Here we're just specifying properties, and you could get some dynamicism by putting one set of properties in a different property file and using a profile. So application-jetty would be a set of configuration that would represent a set of configuration properties that apply only when you've activated the Jetty profile, and you could presumably only do that when you're running the application in Jetty. But it's nice to be able to programmatically interact with these things as well. So Spring Boot features a number of very convenient callbacks, the most useful of which, from my money, is the embedded servlet container customizer. So here I'm going to say my customizer implements embedded container customizer, right? And this is a regular Spring Bean as anything else, so we just override that method there, and we get a chance here to interact with the container. And here we can set a lot of the properties that we saw set in the application.properties, things like the compression, right? There's the compression support, so you pass in a new compression object with the appropriate configurations, or the context path. Again, this is something you can specify right here. Context path, right? There it is, right? That would be this turns into a call to this, right? So the common things are here exposed as setters on this configurable embedded servlet container. That said, sometimes it's useful to, as we say, downcast and to manipulate specific features of the underlying container. So if Tomcat embedded servlet container factory.class.isAssignable from container.getClass. Then, is that the right one? TC, casting it, passing in a container. Is that the right type? Look at the subtypes. It's Tomcat embedded servlet container factory. Yes, it is. So if it's assignable to that, then this will work, and I can say log dot. I'll put a log here. Log factory dot get log. Okay. Log dot info is Tomcat. Okay. So we're in Tomcat, and we can do specific things there as well using the downcast type. So here we can get access to the collection of connector customizers, right? These are the things that actually respond to requests in the actual underlying Tomcat engine. We can get access to the context customizers, and so a lot of the features that we do support for you, we expose as implementations of these two interfaces that we plug into this collection for you. And you can do the same thing. If you have something you want to add that isn't already well supported out of the box, then this is an ideal place to, plugging in implementations of either one of these types of beans is probably your best bet. Now, there's other properties here as well. You can get the valves, you can get the URL encoding, you can get the base directory, you can set the protocol, you can set valves, you can do all sorts of sort of low-level stuff. This corresponds more or less to the configuration that you'd set up in the Tomcat Catalina configuration XML at this point. Now, you're dealing with the very specific implementation details of the container, and hopefully you haven't had to do that. Hopefully you don't need to do that, but it's nice to know that you can. The same is true for the other ones, right? So if Undertow embedded servlet container factory.class.isAssignable from container.getClass, then we assign that. So okay, .class.cast, passing in the container, and there we are. So Undertow dot, add build customizers, add, and by the way, this is another customizer option. This is not natively supported by Tomcat or Undertow. These customizers are a Spring Boot-ism, right? So what you're using here, what you're plugging in are these customizers that get plugged into the creation of the container. So you don't have to override the creation. You can just plug into certain parts of the container. Again, this is keeping with the idea that Spring, at the end of the day, is a framework. It implements the open-closed principle. It's open for extension. You can change the runtime behavior of the application without having to actually change Spring itself, right? Although you can, since it's open source. So log.info is Undertow, okay? And let's do the last one. Jetty embedded servlet container factory.class.isAssignable from container.getClass. And we just do the same thing again. Jetty.class.cast container. Very good. Log.info is Jetty. Very good. Very good. So there we have all three of them. Now let's go see what that looks like. Let's go ahead and run it. What we should see is Tomcat ring true, right? This should be the one and only expression that works here. And that's only after we've successfully signed the container to that type, right? So is Tomcat. There we are. So that worked. We are indeed in a Tomcat application. Now you may be wondering how we can change that, right? As I said, the default behavior, the default configuration for a Spring Boot application when you bring in Spring Boot Starter Web is to also in turn bring in Spring Boot Starter Tomcat. You may not want to use Tomcat. That's fair enough. You might have some application that needs some other specific feature. Whatever you want, right? We're not trying to twist your arm here. So Spring Boot Starter Tomcat, we'll make that provided. That is to say, we're going to exclude this from the runtime footprint of the bundled application. It won't be available when you do Maven dependency tree on the resulting artifact. It won't be available rather in the compiled artifacts jars, right? In the lib directory, if you will. Now we need to replace it with some other embedded server sort of implementation. So let's bring in Spring Boot Starter Jetty. Okay. All I'm doing is I'm going to bring in Jetty. I've excluded after a fact the Tomcat support. And if we do this correctly, assuming I don't have any specific Tomcat specific code, this won't be true anymore. Jetty will be true. So let's see. That should be okay. Yeah, let's go. There we are. So now if we look at the application has started up on port 8010. It's here, available for us. It's an Jetty embedded servlet container. All the same things work. So there we are. If I call greetings with the accept encoding, I get the result as we expect. Let's go ahead and remove the accept encoding header, and I get the raw JSON. So again, that's supported correctly across the different implementations, and so on. So I can do the same thing for Undertow, replacing Jetty with Undertow, and restarting. And there's our application. Oh, I didn't give enough time to restart. I didn't give my IDE enough time to refresh its catalog of class path libraries. There we are, Undertow embedded servlet container. So we've now switched across these different implementations. We've looked at how to work with the underlying types, and again, you can take advantage of all the different features of these containers by using those customizers, right? So one thing that's kind of a common ask is, how would I bind something in JNDI? Well, by default, Tomcat doesn't use JNDI, but if you want to stand up a JNDI context and bind a bean to it, and then make that available as a context reference to your application, you can do that in, for example, one of these customizers, or you could register your own embedded servlet container factory bean, right? So you could register your own Tomcat embedded servlet container factory and override the relevant callbacks, right? Again, Spring Boot just provides these beans by default, and then it passes them into the customizers. But you could provide your own bean like this, right? And here, you can override whatever you want. You can override the post-process context, the configure context, the configure SSL store provider. You can override all these different sort of callbacks, all these different sort of lifecycle hooks that Spring Boot exposes for you when it runs this application. So you can do things like exposing things in JNDI and configuring other connectors that aren't automatically supported for you by Spring Boot. Now, once you've done that, you may decide, okay, well, I've got this application. I want to turn it into a .war application. And there's some value in turning it into a .war, even if you're not going to deploy necessarily to a servlet container. You can turn it into a .war to keep in mind that it may be deployed to a servlet container. And so as an example, we've got this at Undertow. Let's leave it there. Let's turn this into a .war. You can still have executable wars, right? Just because this is a .war doesn't mean you can't do java-jar, or rather java-jar pointing to the .war. So what I'm going to do is I'm going to change the packaging on this. Where's my packaging option? To .war. And down here, well, I think that's it, actually. We need to add some Java code. We need to add a servlet initializer. So I'll create a servlet initializer. We'll say, okay, create a new one here. Initializer. I'm going to say that this extends Spring Boot Servlet Initializer. And the configure method, we just need to point the configure method to our source. So that's the servlet demo application without the initializer, right? That's the actual Spring Boot entry point. That's where the public static void main method is, right? So now, with that done, I haven't gotten rid of the servlet runtime just yet. That's still there, right? But now if I go to the command line here, cd servlet demo, we're in the downloads demo directory, downloads servlet demo directory here. So if I go back to my console, I do maven clean install. We should get a .war artifact as a result of the process. Okay, cd target. I have a .war. I can now do java-jar servlet demo servlet.war. Okay, and there we are. There's the .war artifact, but it's still executable because we've still got the Spring Boot Maven plugin on the class path. Now, it's technically not supported that you deploy, Undertow into, for example, a Wildfly application server. Wildfly is the RedHat JBoss application server, formerly known as JBoss AS, and Undertow is the embedded servlet container subsystem that's part of that application server. In the same way, you're not really supposed to deploy Tomcat into Tomcat, but most of them will detect it and just kind of ignore it as opposed to vetoing it, right? So I can actually take this .war, which is a valid var in every other respect, except that it's got a public static void main and a runnable. I can take that .war and deploy it to an actual Undertow, right? So let's see, servlet .war, and I've got bin, Wildfly, standalone, deployments, right? I've got that. I'm going to put that in there, and I'll run this as well now. Here's my standalone Wildfly application, and you can see it's spinning up the Spring Boot application. There it is, right? There's our Spring Boot application here. Spring Boot 1.52. Can we see our init method is Undertow, right? So there's that as well, my customizer. And the application's up and running, listening on this port, 9999 for management. This is the actual application. Here's the context. So it's listening at server demo snapshot, localhost. So localhost 8080. Greetings. Now, there's our REST endpoint. That's working as expected. One thing that isn't going to be working, more than likely, is, for example, our SSL support or our compression or anything that, or the custom port, anything that we had specified in the Spring Boot application. Here, server port, any of that stuff is not going to work. And the reason is because we're now running inside of a runtime, and that runtime doesn't let guest applications control things like the application server's port and the connectors and so on that are usually reserved for a separate role in a traditional legacy application environment to configure, right? The developer's not supposed to configure SSL. That's supposed to be done by somebody else before the era of sort of DevOps, right? When we had two distinct roles between operations and developers, where they weren't sharing the same code base or responsibilities and same goals. So that is not going to work, right? These properties are distinct features of the embedded container, runtime, the embedded aspect of the Spring Boot application. Okay, so in this Spring tip, we've looked at how to deploy an application, as an embedded jar, as a so-called fat jar, and then how to turn it into a fat war, which you can deploy into a standard sort of application server, a Java EE application server. This is just Spring and Spring Boot, and while Spring Boot keeps a more cutting edge or up-to-date profile than your everyday Spring Framework application, Spring Framework tends to have a longer backwards compatibility story. This should still work on anything that supports Servlet 3.1, right? So that's fairly, that goes back several years now. It'll work just fine on any of those containers that support that. And servlets themselves are a subset of Java EE, so you don't even need a Java EE application server. There's no reason you couldn't just deploy this .war into, for example, Tomcat or Jetty or whatever, right? All right, so thanks very much for watching, and we'll see you next time.